Welcome everyone for today's NPTEL course of Environmental Chemistry, and this is the week 9th live session. I am Saptarshi Bose here, a PMRF research scholar from IIT Madras. Just a minute. Hello, welcome everyone for today's NPTEL course live session for Environmental Chemistry, and this is week 9th live session, and I am Saptarshi Bose here, a PMRF research scholar from IIT Madras. So we'll go for the first question. This is a conceptual question. What is a controlling solid? Solid driving concentration of the metal in solution, or solid having no chance of being formed in given conditions? Just write your answer in the chat section. Yeah, I got first answer. Anurag A. Right? So we'll go for the solution. Yeah, that's correct. Because you see, it was a very easy question. Because this solid having no chance of being formed in the given condition, it doesn't come to the scenario, right? So from the basic understanding, this will be the right answer. And what is happening is controlling solid that drives the concentration of the metal or the ligand that is present in the solution. So that is the controlling solid, you can say. Then this is the next question. Is a ferric chloride or iron 3 chloride? No, nothing but FeCl3 and used as a flocculant in sewage treatment, we all know. And also it is used for drinking water treatment. So when a small quantity of ferric chloride was added to the raw water, iron 3 hydroxide precipitates and adsorbs finely divided solid and colloids. That's their purpose, right? That's why we are using it. And it is assumed that iron hydroxide precipitate is formed in a lab experiment, deduce the composition of Fe total demonstrated in the lectures. So all of you know how to find out what will be the components with the ligands with hydroxide. So please try to find out final Fe total equation, the right equation among these four. So option number A, B, first one, B, then C, and then D. You can refer to the book or some table is given there already in the lecture. Professor showed you how to find out from the table. And also from your basic understanding, you can also. Okay, I got an answer from Anurag. Yes, this is the first one. This is the correct one, right? Yeah, this one. So I will try to explain a little bit. If there is nothing to explain, it's conceptual one. You can go and check. So mostly what will be there, like metal ions will be there, and then metal complexes, and also solid if present. So why we are saying, I'll tell you later. First of First thing is that you go to this table 9.4 or any of the book you can refer. Not only this book, like you can refer to this book, Water Chemistry Introduction, or any other book. You will find the similar kind of chart or table is given, and there you will find the complexes, right? So from here you can see that what was there Fe3 plus, right? That was the basic idea. So when it is taking up one hydroxide an ion, so it is going to from Fe to 3 plus to total charge will be 2 plus, right? Because it is this Fe3 plus is taking up one OH minus, right? So 1 minus and 3 plus. So what will be the remaining? Plus 2. So from here also you can easily calculate, right? There is nothing much to understand. And let's go for this. This is OH whole 2, right? So two numbers of OH. So it will be multiplied by 2. So the total charge will be minus 2. So plus 3 minus 2, it will be plus 1, right? Then here, three number of OH ions. So they are nullifying each other, and that's why there is no charge, zero charge, right? And then again, it will be if there is one extra OH minus ion, then what will happen is four numbers of plus 3 minus 4, and it will be minus 1. So this is how we can get this. And then again, we have to take care of this solid precipitation also, because it was written in the question that it will form some precipitate, right? So you have to take care of this solid or precipitate form. So that's why this the first answer is the correct one. So let's go to the next one. Select the appropriate measure for promoting precipitation in given solution. So go for multiple options. Just a minute. So we'll go for the answer. A very easy one, nothing else. So A, option A and D will be correct one. Because if you see that the what are the factors promoting the precipitation, that will increase the saturation ratio. Obviously, it will precipitate if the saturation ratio is high. and then increasing the solid concentration. If the solid concentration is high, then it will precipitate. On the contrary, if that adding ligand, what will happen? It will form the complexes. If I add ligand, then the metal ions will form complexes, and there will be free metal concentration will reduce, right? So in turn, it will reduce the free metal concentration that is necessary for the precipitation. So it will form the complexes. It will be in the dissolved form inside the solution. It will not easily go to the precipitation mode. Simple thing. And then decreasing the saturation ratio will obviously negatively affect the precipitation process, right? So we'll go to the next one. This is also a conceptual question. In a sample of groundwater extracted from a well, the concentration of calcium ions and ligands is high, right? And can lead to the formation of the following solids. So one is calcite, then portlandite, then gypsum, then hydroxyapatite. So you saw all the chemical formulas as well as their log KSP values are given, right? So you have to check or you have to think how you will arrange them in a order of formation for the above solids. All of them will form, but there will be some order, like some material will form, or some complexes will form, or some sorry precipitation will form first, then second one, then third one, then the last one. So you have to find out the correct order, A, B, C, D. So which one will be the correct? Okay. Yeah, I got answer from Anurag. That is CBAD. Okay, we'll check. Yes, two options are same. Right, right. There is a mistake, I think. Right. So this will be the order CBAD, and why this is the order? We'll check. See, it depends upon this KSP value, right? So depending upon this KFC value, you can see this is the bigger one. So when it is going towards this 58.33, this is the smallest one, right? This is the minus, not plus. So take care of that. We know that that's why. So this is the highest KSP. Then this is the second KSP. This is the third KSP, and this is the last or fourth KSP. So that will be the order C, B, then A, and then D. So this is the correct answer, right? Next question is a similar kind of question. A solution contains 0.0010 mole of Ki and 0.10 mole of KCl per liter, right? Then AgNO3 is gradually added to the solution and observed. After some time, a precipitate was observed in the solution. Then it was concluded that it could be either silver bromide, AgBr, or silver iodide, right? And these are the following equations or the reactions. So AgCl, uh, it is getting broken down as Ag plus Cl. This is the equation, and this is the equation for iodide, right? AgI. So yes, there is a this is wrong. This will be AgCl, not AgBr. Please take care of it. This is not bromide, silver chloride. So please take care of that. So either it will be AgCl or AgI. So case values are given considering the following statement regarding the formation of the precipitate. I will go for the solution. So the answer is B. The solid with higher log Ksp will form first. Right? And then this is the next question for our experiment of silver bromide solution was made by dissolving AgBr in the water. So the following equation is given, and the forward reaction G value or the Gibbs free energy in kilojoule per mole is also given. So you can find out the values 77.12, then 96.9, the chromium minus 104, and the temperature is standard temperature of 25 degrees centigrade. So find the solubility product of the solid, that is log Ksp. Let's quickly calculate this and I do answer. This is also very easy numerical with a very common or small equation. Okay, we'll go for the solution. So the answer will be minus 49.93, and we all know this thing, right? Del G or the change in Gibbs free energy equals to minus RT ln K. So we can find out this K value, the constant value or ln K value, better to say. That is our question. And these are the data which we have GF. So please try to think that this is the it is given in terms of forward reaction. So this is written as AGBR, then it is forming AG plus BR minus, then there is a sign that is a forward and backward reaction sign. But you have to take care from this side only. Like it will be reverse AG plus BF minus, then this one is forming AGBR. So this will be the correct order for me to find out which one is the reactants, which one is the product. So it will be better for you to write down like this. So then you can find out, okay, this one is the product and this one is the reactants. So the solubility product we have to find out. So I'll write down these things, and we all know that the change in Gibbs free energy del G naught equals to the summation of the all Gibbs free energy of the products and also minus the summation of the all gives free energy of the reactants. So I'll write down whatever in my product side, that is AGBR here. It is the product side 96.9, then minus 77.12 minus 104 kilojoule per mole. Here everything is 1 mole, so no need to multiply with anything else. So I'm getting 1237880 joule per mole. That is my del G uh, or the change in Gibbs free energy. Then I will put this value to this equation. This is the basic equation we know. So this is the gas constant. We know the value of the gas constant 8.314. Then this is the temperature 25 degree in Kelvin. You need to convert it into Kelvin. This is T, capital T in Kelvin. So this is 298.15. If you just calculate, you will find minus 49.93. So let us go to the next question. Consider the following statement regarding the formation of precipitates in a supersaturated solution. Rates of nucleation and crystal growth are heavily dependent on saturation ratio. Then rate of nucleation depends on saturation ratio. Then rates of nucleation and crystal growth are heavily dependent on surface area density, or the rate of crystal growth depends on the surface area ratio. Just think this A 1, 2, 3 as ABCD. There is a mistake, like it should be ABCD. So this is A and this is B. Okay, we got an answer from Anurag, B and T. So this one and this one, right? So the rate of nucleation depends on the saturation, and also the crystal growth depends on the surface ratio, right? So your answer is C or B and D. And everything is known, so there is no need to explain again. Let's go to the question number 8. So this is a numerical question, right? And I will suggest you to use VMinTech software for solving this one. The massive industrialization and urbanization of civilization during the last few decades have made a and metal pollution, heavy metal pollution in the various river bodies. So a similar industry was selected for analysis, and we got that the concentration of different ions or different elements, the chlorine, total chlorine is 10 to the power minus 2 molar, then zinc 3 into 10 to the power minus 5 molar, and then carbonate, and also pH is given 8, right? Is assumed to be possible the solid formation as ZnCO3. So determine the dissolved Zn concentration, zinc concentration in the samples taken. And also take care of this that the total Zn refers to the total zinc concentration in the aqueous solution. Okay, we'll go for the solution because answer will be A. That's the correct answer. Go to the WinMinTech software and first here you will find there is a pH section, right? Fix that. Go for fix that at pH 8. So this is your first thing. Then go for this add component section and add your components and also go to the view and edit list. So this is the view and edit list. Go and check whether everything is correct or not. So what are my components? So these are my components, right? Chlorine and then Zn, then CO3. I'll check. Yes, the chlorine concentration is uh, how much it was? 3 into 10 to the power minus 5, right? And Zn 5 into 10 to the power minus 3. Yes. So chlorine concentration is 10 to the power minus 2 only. Then Zn was 3 into 10 to the power minus 5 and then carbonate 5 into 10 to the power minus 3. So that is the concentration. Just give the inputs here. Here in the drop down, you will just give the inputs, and if you go to this view and edit list, you will find this list. Okay. Then again go to this back to this main menu. Then there will be an option like specify the infinite solid species, right? At the top menu bar, you will find that. Go there. After going there, click this, and then you will find some list. This will limit you to the components which can form during your particular reaction. Not all the components which are there already loaded in the software, so it will not come. So it will only send you the relevant components which are relevant to your equation, this particular problem, with all those inputs like the input components, right? So it will limit. So at the top menu, you will find this option. Go there from this drop down. From this drop down, this is our target one, right? ZnCO3. It was given in the question also that is a precipitate form. So just from the drop down, select this, go for the add, then run vmentech and click the equilibrated mass distribution. If you just run this vmentech, I'll just show you a little bit. I hope it's there. So if you go here, the solid phases and excluded species, you will find the specify infinite solid phases. So if you go there, infinite solid phases, you will need to click this, and then from this drop down, first you need to click this. From this drop down, you have to select something. So it was for a different problem, so that JNCO3 is not coming, but for your problem, this will come. So first go here, fix that pH at 8, and then from this place, select your components, then add to the list, then view this edit list, then go here, specify infinite solid phases, select this, click here, and then go to the name of the solid, select, add, close, then run vmentech. If you run vmentech, you will find the table, right? So this table you will find. I hope it is very much clear for everyone. And from here, you can see that Zn2 plus is the dissolved concentration is 2.34 into 10 to the power minus 6. So that is the dissolved concentration of Zn, right? So I'll go to the next question. Now the connected question, same data type question for question number 9 and 10. So a township is being planned near to that industrial area, and in the planning and development process, it is visible that we need to go for some alternative drinking water, right? And the surface water being evaluated for a possible drinking water supply source. So preliminary testing is saying that the pH is 7.5, total calcium ion concentration is 185 mg per liter, right? And then determine the alkalinity of the solution in terms of mg per liter as CaCO3. So carbon dioxide is given, the equilibrium carbon dioxide. So it is equilibrium with the carbon dioxide to simulate the real world condition. And you have to take the atmospheric carbon dioxide pressure as 0.00038 atm. Use Vim-Tech to determine the alkalinity of the solution. So unit will be in mg per liter as CaCO3. So we'll go for the solution. So first open this vMinTech and add the pH. pH is given right 7.5. Fixed at, go here, fixed at 7.5. Then add Ca2 plus and concentration as 185 mg per liter. Change the unit from here, mg per liter. Then from this drop down, select Ca2 plus as 185 mg per liter, right? And then go to specify gases from the gases tab, right? So go to the specify gases from a gases tab. You can specify and then specify at its carbon dioxide pressure. It is as 0.0038 atm pressure. So now you need to change anything, just one. One is okay. Go for add and then run vMinTech. If you run vMinTech, you will find this is the concentrations from the concentration table. So all of you know how will it look. So it will be something like that. You will find the concentrations from here. The pH is 7.5, ionic strength given, and all the other things are given. You'll find this table, right? So from here, you note it down that what is the bicarbonate concentration, that's carbonate concentration, H plus concentration, OH minus concentration. So we know what is the alkalinity formula, that is bicarbonate plus twice carbonate plus OH minus minus H plus. Basically, it can take up the H plus ions. That is the concept. So it can take up one H plus ions. It can take up two H plus ions, and similarly, OH minus can take one H plus ions. So that is the concept behind this, and we have to need to subtract the H plus what is in the from it, what is in the form with these H plus ions already with having H plus ions. So we have to subtract that much, right, from the total alkalinity. So we'll get this net alkalinity, or better to say, this is the total alkalinity available in the water. So that much of H plus ion it can take because other things are already taken, right? So I hope you can understand what I'm saying. Then you just need to put the values, nothing else. Put this 2.01 into 10 to the power minus 4 here. Then displace a bicarbonate. Then twice into this 4.02. Then OH minus 3.59 into 10 to the power minus 7. Then H plus. And if you just calculate, then you will get that 10.105 mg per liter as COCO3. So I will always suggest you this is given in the molar concentration. So I already told you how to convert from molar concentration to mg per liter as COCO3, how you can use this equivalent weight concept and convert. So it's already discussed in many previous live sessions. So I'll not go deep into that. So just you need to convert this. This will be in the molar concentration, then you convert this. So I know how you know what is the meaning of this 50. So at the end, I am getting 10.105 mg per liter of CO2. Let's go to the last question. So fill in the blanks with respect to the calcite solution. Is with respect to calcite solution, is it under saturated or oversaturated or supersaturated or cannot be determined. From the vMinTech software only you can be able to answer this. So go for the solution. It will be answer A. It is undersaturated. How I will find. So you have already calculated for the previous question, right? That question number 9. Then go to this tab. Let me show you if I can. So just click here. You have this table, and at the bottom you can find this view species distribution, then display saturation indices, and then equilibrated mass distribution. If you go to this display saturation indices, you will find this another table. So here you can find that the red text is over saturation, blue text will be under saturation, and green will be apparently equilibrium. So if I go for this cal sheet, it is written in blue color, right? Minus uh, zero point 0.6. So this is undersaturated. So my answer will be undersaturated here. So with respect to cal sheet solution, it is undersaturated. So I hope everything is clear. So this is the table which I told you. Thank you everyone for joining today's session. Hope we will meet on next Saturday at the same time. Thank you everyone. So now you may leave now.